Hi, everybody. Uh, Today we are going to be talking about the peopling of the continent and the Paleo-Indian period. So this is, we're shifting from the conceptual kind of undergirding ideas that organize how the class itself and focusing in on that story, on what we learn about the past. And one thing to keep in mind is I'm going to give you an archaeological perspective, and you have the textbook reading, which gives you a very good overview of the archaeology on the Paleo-Indian period. And you have the article from the Page Ladson site, which gives you a concrete, specific example of that research, of a publication from that research, and what people are doing in that field right now. And, I will say one thing that I love about this textbook is that they start this chapter off with a Hijri oral tradition. Hijri is a language group in the southeast. They become a part of the Muskogee Confederacy. The Muskogee Confederacy is really an alliance of several dozen towns that maintain a pretty high degree of political autonomy from one another. And many of these towns speak different languages, have different cultural practices. It's very much a multicultural society. So according to oral traditions, Hijri people, there's these oral traditions that explain encounters between Hijri and Muskogee peoples, as well as the migration of the migration story of coming to this area that later becomes known as, at least for the time being, Georgia, Alabama, and northern Florida. I say for the time being because archaeologically we're thinking here in terms of tens of thousands of years. I do not expect that in another 10,000 years that place will be called Georgia. Colonialism is a temporary phenomenon. One thing that we see very clearly in archaeology is that the nature of the state is to collapse. Everything is impermanent. Anyway, I love that Pocketot and Sassman start off with an oral tradition, right? Because many of these stories, sometimes oral traditions can be interpreted as being analogous to archaeological narratives of the peopling of the continent. For example, there is a famous indigenous studies person. I'm actually blinking. I think it's Gerald Visnor, but it might actually be a different person. Um, no, it's not Visner. I'm sorry. I'm just forgetting who it is. It'll come back. But anyway, he has this argument that in many stories there's this kind of narrative of coming through a dark place. I forget exactly the details of the story, but he argues that it is similar to and could be interpreted as a memory of the Bering Strait land bridge, which is a migration model that I will get to later in this lecture. Other oral traditions, however, don't do that. For example, in the Southwest, a lot of oral traditions are that people came from under the world underneath to this place, and they appeared here in this place and lived there since time immemorial. We'll see this next week, for example, with the Cherokee oral tradition. And so many indigenous oral traditions will have competing narratives. Some of them can be made to fit the archaeological stuff we see. Some of them we have to figure out other ways to interpret or understand like those differences. And archaeology is always in process. We never know anything for sure. We're always making models and inferences on the basis of the available evidence, which is very partial and scant, right? Particularly in this period, we're going to be talking primarily about bones and stones. That's the evidence that survives this long. It's not that much. So there's a lot of inference that we have to do to get from the bones and stones to human beings. And it's just worth kind of keeping these tensions in mind. And of course, in indigenous communities, different people have different perspectives. Some people interpret oral traditions literally, other people don't. There's all kinds of ways that people, whether they're archaeologists or indigenous non-archaeologists, approach these kinds of things. So here's my overview for today. I'm going to go through a bunch of language and background concepts for y'all. If this is familiar for you, feel free to skip it. However, if this is new information, because maybe you haven't taken Intro to Archaeology or something like that, hopefully this will bring you, it'll give us some shared language. Following those background concepts, what I'm going to do is I'm going to give you an overview of the Paleo-Indian period. Now, if it makes sense for you to cut this lecture into 2 parts, watch the first part and then let your brain rest a bit and then come back to the second part, feel free to do that. That's part of why I'm offering so much background concepts right here, is because this is a good way, because it is remote, that you can break the lecture up into smaller chunks and digest it better. This is the same image, the same chronology that I gave you, what's the word I'm looking at, last week. It's just a general chronological sequence for the region of the Eastern Woodlands, which is the region that we are in here in this part of the eastern third of the United States or so, is the woodlands. It's a ecological zone that over time has, it's an ecological zone, and as such, like, people's lifeways are adapted to this particular ecological zone, so that's why we divide the regions in these kinds of ways. Of course, there is often interconnection reaching beyond the woodlands. People are interconnected. However, actually, one of the things throughout this period is, like, this region, people in this region, the Eastern Woodlands, are very much connected to one another. And there are connections that go beyond, but they're not necessarily as high volume in terms of, like, trade as what we see internal to the region. Now, if this chronology was confusing for you, after I introduce these next few concepts, then the concept of chronology will probably become a little more clear. Because actually what we're looking at when we talk about chronology is we're specifically looking at very concrete forms of evidence, which is going to be the stratigraphy, or patterns we see in the dirt, and artifacts, primarily ceramic and projectile point variation. In order to move forward as archaeologists, we really need to understand when something happened. It makes a big difference if we're talking about something that happened 10,000 years ago or 1,000 years ago. So chronology is our tool for locating things in time. We tend to think about chronology in terms of periods. Periods we tend to define in terms of broad, general similarities in terms of material culture or lifeways. Environmental shifts. Those tend to be the factors that determine where we put the boundaries around our periods, our periodization. Now, this is something that can be quite, maybe contentious is the right word, but it's worth problematizing, because in indigenous communities, one of the things that people often say about archaeology is when we focus so much on periodization, we're emphasizing the differences between these periods rather than the processes and the continuities across them. So it's absolutely like just a little like fictional trick that we play. It's a way of seeing, given that we're looking at material culture and patterns in the soil. It's a way of locating things, but it's an imperfect one. It's one that does actually have its own internal cultural assumptions built into it. And actually, a lot of my research is about challenging these kinds of ideas of discrete starting and end points. However, you do need them as a starting point. They are helpful in generally locating things in time. So we think about these as kind of blocks. blocks of time. Now, in the Paleo period, the Paleo-Indian period, we are looking specifically at a Holocene ecology. This is the Holocene, Pleistocene. I used the wrong word. This is a Pleistocene ecology. The Pleistocene refers to the last ice age. It's followed by the Holocene, which was for about 10,000 years, the environmental conditions of planet Earth. Now we have entered into a phase that geologists are calling the Anthropocene, which is essentially the period where now human-driven climate change is marked in the geological strata of the Earth itself. So technically we are in a new climate age as of pretty recently. Different people debate on when we should set that time period. Some people argue 50 years ago, or I guess 70 years ago now. Other people argue we should think maybe 400 or 500 years ago. We'll actually come to that question later in class. So here we're in the Paleo period, defined by a particular ecological niche in which the climate was quite different than it is today, and defined by particular kinds of stone tools or lithics, particular kinds of material culture that are adapted to living within that kind of ecology. Okay, so when we look at a chronology like that, what we're actually doing is we are representing visually a it's almost like metaphorically a stratigraphic representation of what we would expect to see if, in a hypothetical example, we had a site that included inhabitations from all of these different periods in time continuously. So this is the most important piece of archaeological data. What matters is the context. An archaeological object, an artifact, is actually not that significant, scientifically speaking. It's not that interesting by itself. The only reason it becomes interesting and becomes useful as data is because of the context we found it in. Because the context, which I will explain, is what tells us where it is in the site and where it is relative to all the other things we found in that site. It's how this object relates to everything else around it. Without that contextual information, we have very little. So to help explain that, I'm going to explain this idea of stratigraphy, and then I'm going to come back to the example from last week of Clarence Bloomfield Moore to help illustrate why that context is so absolutely essential. So when we talk about stratigraphy, what we're really talking about here is the layers of soil that build up. And if you think about a cross-section, if you dig a hole down and create a cross-section, or what we would see is multiple layers of soil stacked on top of each other. In normal conditions, this is what you would see. And the soil will have these layers that will be differentiated by virtue of the color of the soil. It might be a different color of dirt, or the texture might be different. It might have more clay in it, it might have more sand, things like that. So we look for differences in texture in soil. And the idea is that over time, new layers of soil form on top of prior ones. So that means that the layers closer to the top represent more recent formations, and the layers lower down represent older formations. This is useful because we're starting to see how the artifacts we find, how they are located in time, by analogy to how they're located within the dirt. Now, if you've ever gone to, for example, a canyon, you can look at the walls of a canyon and see that stratigraphy. That is a geological phenomenon. We are going to be looking particularly at the human consequences in stratigraphy, but there's also the natural phenomenon, right? And again, if you look at a canyon, you will see that there are layers of different colors going down in that canyon. That's stratigraphy. That's what we're talking about here. And what you can see in this nice diagram is, first of all, you have different objects are located in particular stratigraphic layers. Stratum A, B, C, D, or E. And again, we can see they've represented these different strata using different colors. The top layer is more of a yellow dirt, the middle layer is a bit redder, the bottom layers are more black. And we find different objects located in these strata. This is useful because now, again, we're putting these things in reference, in relationship to each other in time. Something that comes from stratum B, an artifact that comes from stratum G, like this glass bottle, will represent something that happened later in time, more recent history, compared to the pottery fragments you see in stratum E. So we know now that whatever happened with those pottery fragments, whatever happened that led to these objects entering into the dirt, entering into the archaeological record, that happened earlier in time. So here you can start to see how this is becoming very useful. This is another diagram of stratigraphy. This is again just illustrating that same point, right? That these stratigraphic layers, we give those layers the names of periods because that tells us, hey, this stuff all happened in this period. That period may be several hundred or even several thousand years long, so we don't know exactly where it happened in that larger time frame. However, we know it was somewhere within that period, right? So now hopefully the idea of a period is making a little more sense to you. And so in this example, you have two kind of essential layers. There's the natural geology and the human activity. So again, the idea that stratigraphy, that's a normal geological process that happens through like Earth's normal processes and tectonic whatever. And then above that, you have the human activity. These are stratigraphic layers that have human presence demarcated in them. When you're doing a dig, right, and you excavate down, the deeper you excavate, the older the material you're looking at is going to be, under normal conditions, again. Once you reach the bottom of that human activity, and you get into that period where you stop finding artifacts, the way we refer to that is you have reached a sterile zone. So once you reach that sterile zone, we usually stop digging as archaeologists because you're not going to find anything below that. That's at least useful for us, considering that we are studying archaeological activity. But here you can see this nice way of how these periods map on to the stratigraphy, right? So the bottom layer in that gray period at the bottom of the human activity, we have prehistoric, followed by Roman, followed by medieval, followed by early modern, followed by modern. This is the exact same kind of image that you're going to see in a chronology, right? If you scroll back up to the chronology for the region that I've given you, you will see we put the oldest periods at the bottom in order to mirror the chronologies we see in the dirt. Now, I keep saying that this is under normal conditions. There are definitely conditions where you see all kinds of weird things. For example, where you have rivers, you're not going to see you might have a different layer of you might have a different process of stratigraphic formation where the different layers might be located diagonally or even horizontally instead of up and down. But almost always we're going to be looking at it this way, in an up-down way. Now there's some language here that might be worth mentioning just in case they come up so you're familiar with them. When we refer to an object being in situ, that's Latin for it is within, that is where we found it in the dirt. So for example, you're excavating, you come to this really cool object, I don't know, like a whole pot. We rarely find whole pots in the dirt because what we tend to find in the dirt is things people throw away. And so if you have a whole pot, you're most likely going to continue using it. And so it's not going to enter the archaeological record. It's not going to enter into the dirt. Only after you break it do people throw it away, and then it gets covered up by newer forms of dirt, newer layers of dirt. So in situ means that is where it was found in the excavation. You're digging in, you find that whole pot, and you take a photograph of it before you even grab that pot and pull it out from the dirt. It is still physically attached in that place. That means it is in situ. That is right where we found it. If it's not in situ, then that means, there's all kinds of things that could affect that. I'll get to that in the next slide. The other piece of language you might encounter just offhand is going to be the idea of a horizon. The way so if you look at the stratigraphy and you see how you have these horizontal lines, it looks like a horizon, metaphorically speaking. So we can talk about the early modern horizon, medieval horizon, or the sometimes you'll hear like Horizon A, which just refers to like that kind of top layer of like dirt and grass that forms at the very, very, very surface. It's just a metaphor for talking about chronology. Now here, we're going to get complicated. I'm going to give you a much more complicated example of stratigraphy. So here in this picture, you see multiple stratigraphic layers that correspond to different periods, and you see all kinds of weird human activity that intrude throughout these horizons. So you can see, generally speaking, there are these general periods, right? At the bottom you have the natural subsoil, that's the sterile layer, above which you have Iron Age soil, then a Roman leveling dump. So that's a construction activity. Then you have a Roman road that was built. Then there's a later Saxon clay period, or a Saxon clay floor, a medieval garden, and so forth and so on into the 18th century. Now, when people dig into the dirt, they cut into those previous layers. So when you see a pit like this, and the pit will be defined because it'll be a different color of dirt, or you might even have like a physical wall in it, right? When you see a pit or something that intrudes into a lower stratum, the way you date that pit is you look to see where the surface of the pit is. And the surface of the pit, the very top part, is going to correspond to the very top part of a stratum. The top part of the pit was dug. That means it was dug in the stratum where that top part is. So here in the center you see that big medieval pit. That's a darker gray. The soil is different. And it was dug. You see that it matches at the top of that medieval floor, right? So we know that was a medieval pit because they dug down into the older layers. So you have to be careful, right, with those kinds of intrusions. At the very bottom, for example, you have that natural subsoil. That natural subsoil is sterile, but in the Iron Age, people dug pits into it. There's a ditch, and there's a post hole with a burnt post. What that means is someone basically dug a hole and stuck a post in it. Most commonly, people do that when they're building houses. So this is probably some sort of house or structure or something like that. So you dig into the previous layers. So this is important because when you look at when you look at profiles from excavations, you're going to see the stratigraphy, and this is how you interpret it. Now again, we use this information because it's super helpful for understanding when things occurred. All the objects you find in that Iron Age stratum, defined by that color, are going to have been used in that same general period of the Iron Age. We know all of those objects are somehow generally related to each other in time and space. So that gives us the context for understanding these objects. Now there's other kinds of processes that can affect where we find things. For example, bugs or moles and rodents that dig into the dirt. That can move stuff around, that can move things between layers. What we refer to in that context is that those are disturbed contexts. Those are contexts in which the artifact's location Its broader context was disturbed by some sort of activity, whether human activity or animal activity, or even like roots can bury down and push things around in complicated ways, etc., etc. Now, there's all kinds of ways that the archaeological context or the stratigraphy can get disturbed. One way, so for example, when I was digging at a mound site in Alabama, I'm sorry, not Alabama, in Georgia, outside of the town of Albany, these are sites that had been plowed for years and years and years. So there is what we call in archaeology the plow zone, which is the area of dirt going downward from the surface that has been turned up by the plow. All the different stratigraphic layers get mixed up by the plow. So we have there's no archaeological, like visibility there to what's happening in that period. It's all just one mixed up context for all of these periods. And it's only below there that the stratigraphy and the context becomes a little more clear and precise. So you just kind of always have to be paying attention to these kinds of things so that you can understand the context, the stratigraphic context of where these objects come from. Without that, you cannot understand anything about ancient societies. I'm sorry, that's an overstatement. You can't understand nearly as much about ancient societies. Now, this is the situation where the case of Clarence Bloomfield Moore, who y'all read about last week, gives us a bit of a cautionary tale in terms of the importance of stratigraphy and context. So Clarence Bloomfield Moore was basically a rich dude in the late 1800s who had a passion for archaeology. And what he did was he took his steamboat, called the Gopher of Philadelphia, which is quite an interesting name in the context, and basically went up and down rivers across the southeast, excavating large mound sites very, very quickly and rapidly. Now, to understand this practice, you have to understand how it made sense within the particular historical context. In the late 1800s, keep in mind, first of all, we talked about the professionalization of archaeology in the 1910s. So this is before there was a strong distinction between professional archaeologies and amateurs. So he's not necessarily a professor or trained in these ways. He's just a guy with a lot of money and a steamboat, right? And that's a part of the context of who's doing archaeology at this point in time. The other pieces, too, are that in this point in time, archaeology is primarily tied to museums. And it is prior to the crystallization of certain scientific techniques that we use today, including the ideas about how we can read stratigraphy to get the larger context for these things. So the stratigraphy, right, this is Clarence Bloomfield Moore is operating before the idea of stratigraphy was really commonly spread throughout people doing this work. That was a later idea. So he doesn't have that cultural context. He doesn't have that reference point. And what he's doing is he's primarily working on the basis of finding collections for museums. It's museum driven. And what museums, particularly in this point in time, are really interested in is cool shit they can put on display, right? Again, keep in mind also, like here you have like the Peabody at Harvard and like the Chicago Museum and the Smithsonian. All of these museums are like kind of competing with one another for prestige. Who can have the coolest shit in their collections? So they're looking for cool shit to put on display. What we're not interested in are the kinds of less visually interesting everyday items, the things that people use in their everyday lives that tell us maybe more about how they lived in their social organization, because that's just not, we don't even have at this point in time the scientific techniques to arrive at those kinds of interpretations. And so Clarence Bloomfield Moore is going through and he's excavating all of these different sites. He's excavating so many sites so quickly, right? Today, like, if you were to dig a site today, I mean, year one, what you're doing is you're actually doing just surface survey and shovel tests. You're looking to see where artifacts are on the ground, or maybe you're digging like a small pit with a shovel that's going to be maybe like 10 centimeters or so deep and 10 centimeters wide, because we do use metric in archaeology. And if you dig a shovel test like that, at every point along a grid, every 10 by 10 meters, you can then use that information to like identify statistical distributions of where artifacts are. So you can say, oh, hey, we find more artifacts here and less over there. So when you want to do a more deep excavation, a more systematic excavation, you know where to put that pit now. And when you do that, so that would be year one. It's just like testing the survey, doing some shovel tests. Maybe year two, you start digging some excavations. And year three, you'll do some more of those excavation pits. And over several years, you uncover more and more of the site. Now, most sites, our sample of what we've dug up from the site is pretty limited compared to the larger site. We often are working with a very small fraction of the larger site because it takes a lot of labor to dig. So Clarence Bloomfield Moore is going astronomically, like mind-bendingly faster than contemporary excavations. And so as a result, right, he's not really being particularly careful. He's digging things real fast and looking for the cool shit. We don't care about the ceramic sherds as much as we care about the whole pots, because that looks cool on a display. And that has created a situation where we as archaeologists today have these massive collections that are available to us because Clarence Bloomfield Moore dug up so much shit in this style. However, the objects in those collections have very limited very limited contextual information. We have the objects, but we often don't have very much context about where they came from in the site. We have enough context to at least know what site they came from, which is very important. It really does matter if this object came from like a site in Alabama versus a site in Indiana, or even two sites within 50 kilometers of each other in Alabama or South Carolina, right? We need that information. But what he doesn't have is the contextual information about the stratigraphy, where these things were found in the mound he excavated. We tend to have much more limited information in terms of that, which means we're not able to get a very fine-grained view or lens in terms of how these objects relate to one another. We often don't know what came before from earlier layers and what came from later layers. We don't know how these things fit together in the same way. So when we don't have that context, overwhelmingly, the objects themselves become scientifically meaningless. They have limited to no scientific value for archaeology. They might look cool on a museum display, but we can't actually learn that much from them. Now, sometimes there are things we can learn from, even without that context. For example, we might be able to say, like, in particularly like robust artwork, or complicated, like things with complicated designs. We can say like, oh, this is a design commonly used in that period, and we can find some context that way. Or in the case of art, it could even give us something interesting about like a story or a narrative or a spiritual belief system, where even if we can't pin it down precisely in the site, there is still something useful we can gain from it. But if you look at, for example, a collection of 7,000 flakes of stone made from like stone tools, or 7,000 flakes and stone tools, different pieces of lithics used in people's everyday lives, that now lacks any particular, that becomes completely scientifically useless. And that is the bulk of what we are looking at. So we're going to go to that next. But for now, Clarence Bloomfield Moore is a cautionary tale of, as an archaeologist, we live for context. Context, context, context. That is the only thing that lets us make sense of the objects we're looking at. Without the context, the artifact is not meaningful. And so archaeologists today, it's a kind of funny place to be in this contradiction, right? I have books in my office of Clarence Bloomfield Moore's excavations because these are really interesting objects. They're really big collections. And as a result of this, and the practice itself was actually very destructive. So, archaeology is a kind of funny field of science. We say that our methods are usually destructive in nature. We destroy our evidence as we excavate it. As we make our evidence, we're also destroying it. Because once you take that artifact out of the dirt, you never have that in situ context again. And so if you don't document it properly, if you don't take notes, if you don't make drawings, that data is lost forever. We have destroyed it. So we are one of the few fields where we actively are destroying our own data sets. Now, there's a few ways we do this. We handle these. First of all, there are certain methods, there are techniques, particularly today, we describe them as non-destructive. I mentioned that last week. You have ground-penetrating radar, for example, where you're not digging, you're just sending pulses of radar down underneath to see what it bounces off of. Or similar kinds of practices looking at magnetic variations. Those are non-destructive methodologies. On the other hand, we also have methodologies that, when we do use a destructive methodology, like when we do an excavation, it is best practice to leave at least half of what you're digging untouched. That way, down the road, people who might have better technology and might be able to look at things and find information from things we didn't even realize were interesting or useful or important can then redig that other half and learn even more. So as a good practice, we try not to excavate everything. We try to leave some. So why do archaeologists care so much about projectile points and about ceramic sherds, pottery sherds? These things look pretty non-interesting and nondescript to most other people. Why do we care so much about it? We care so much about it because there's a lot of it in the archaeological record. People make a lot of these things through the course of their everyday life. So they're making a bunch. And it's just pretty they break relatively, frequently, and they're disposed of, meaning people throw them away, and we get to see them archaeologically. So when I gave you that example of what if you have 9,000 different pieces of lithics, and those 9,000 pieces, that could include all kinds of things from tools, but also just random flakes and bits made as you're working that stone tool. I'll talk about that a bit more in a minute, right? So you can have huge quantities of objects. Same with ceramics. We often find huge quantities, hundreds if not thousands of pieces of ceramic fragments. And so what we do in archaeology is we look for subtle variations in those things, particularly in how they are made and in their form, meaning what they look like. Their shape, basically. And we make the assumption as archaeologists that people's material culture changes relatively slowly, sometimes quickly, over time. So the styles that people use at one point in time might be different than what they use later in time. Likewise, the styles people use at one place might be different than the styles they use another place, 50 kilometers or 100 kilometers further down the road. We look at those variations to start making these distinctions of these are from different time periods. Oh, these are from different sites or communities, right? That also helps us understand connections with different sites, right? If you find an artifact that's normally from 100 kilometers or 1,000 kilometers over, that tells you something about how people are moving between these two places. But seriation, specifically, is a technique by which we take these objects and we take these shifts in styles and we try to make an inference, or we interpret information about the chronology, the chronological context, when these happened in time. And so here I have this, basically it's a diagram that explains different projectile points that are used at different time periods within the Southeast. Now this is upside down. I'm not sure why. It actually does bother me to have the oldest dates on top. That's not the convention, but just go with it. So what you see is that top layer, those are the paleo points. As you go down, we're seeing styles shifting later in time. Now, often there are technological reasons why we see these shifts. For example, those paleo points, those are artifacts designed for taking down very large prey, megafauna, things like mastodons. I'll come back to that in a bit. As those megafauna, those species go extinct at the end of the Ice Age, technology shifts as people hunt different animals. By the time, within the last 1,000 years, we see these very small triangular points. These are tiny. These images are not to scale. The triangle points, like that might be like, I don't know, maybe like 10 centimeters, maybe 20 centimeters, whereas a Clovis point, like that's going to be like the size of your hand. So big variation in size. Those tiny triangle points, those are arrowheads. Everything else is a spear point. So arrows are invented as a technology, I forget exactly when, but relatively recently, within the last 1,000 years or so. And so we only see those technologies later in time. As a side note, this is why in archaeology we describe these objects, these stone tools, as projectile points, not arrowheads. In common language, people tend to call all of these things arrowheads, but that is incorrect. The vast majority are spear points, not arrowheads. So we use the term projectile point as a catch-all for all of these things. So, basic premise, styles change over time. Simple premise, useful, it gives us a very useful way of looking at the archaeological record. And the way we take these collections, these assemblages of objects, it's not just one object, it's an assemblage of many, many objects, and we get from that assemblage to a model of change over time, or stylistic change over time. What we do is we basically look at the proportions of how many of one type of object or one style of object relative to the others do we find in different contexts, different stratigraphic layers, different test pits, different excavation units, different sites, whatever it is. We look at the statistical ratios of different styles together. And we organize those styles to make what we describe as these like nice little battleship curve distributions, where essentially our assumption is, again, styles are changing slowly over time. As some styles go out of popularity, others come into popularity. It's a really simple set of assumptions, and this is the inference that we can make based on those assumptions. So in this diagram, as an example, you have 4 different types of ceramic objects. You can see that they vary from one another in terms of their form or their shape. They vary from one another in terms of their decoration, the way they are decorated. They also could potentially vary from one another in terms of their manufacture techniques. For example, when you make ceramics, you need to add in something called a temper to the object, to the clay, to make it a bit stronger, and I forget exactly how it works on a kind of chemical level, but I think it has to do with the air bubbles and things like that. You can use all kinds of different tempers. Some people use shell, ground up shell. Some people use sand. You can use all kinds of things. Some people use like ground up grasses of certain types. And so that's another variation you can look for. People tend to, like if things are made with a different manufacturing process, that's a change that can be over time or over space. So we have these 4 different styles. And then on the up and down row, the vertical row, you see the strata, 1 through 24, right? So these are all different archaeological contexts. And from that context, or in this case from that strata, we get a collection of different objects. For example, on strata 18, we have a pretty good amount of these round flat balls, and we have a pretty good amount of these much taller but wide-brimmed faces. There's very small, narrow-brimmed faces and very few cups. Now, this is just a silly example, right? Because, of course, people are going to be using cups and bowls. You know, like, it's not, the variations are usually not going to be like people use more bowls at one period of time. It'll be the art or the manufacturer or the style for making a bowl will shift. But as a silly kind of example to illustrate the point, this works quite well. So basically, you look at all those strata, and then you arrange the rows to try to get these battleship curves, in which we say the objects start off, you know, when they're first introduced, these styles aren't super popular, but over time they take off and become more popular before fading out of fashion. And as they're fading out of fashion, other styles are coming into fashion and gaining in popularity. So if you don't, for example, if you don't have that stratigraphic information of, hey, these soils of dirt are literally on top of each other, you can arrange your assemblages from each archaeological context like this in order to say, oh, this context came before that one. Now this might be really useful. For example, let's say these objects didn't come from just one excavation where you have a clear stratigraphic distinction between each of these 24 contexts. Maybe some of them came from a pit, an excavation unit that you've dug here at one part of the site, and others come from excavations you've dug at other parts of the site, and you don't know exactly how they relate to each other in time. Seriation lets us say, like, oh, this is likely happening at this point relative to these other places. Based on this hypothesis, again, things come into fashion and come into fashion and then come out of fashion. So basically, we're using variations in style and manufacture to come up with a sense of where things are in time. So if you dig any excavation unit at any place, right, and you come to this style of ceramics, this flat and wide style, that tells you you're probably looking at something at this later point in time relative to the other things you're looking at. Now, one of the tricks you have to be careful about with this technique is it's sometimes possible if you aren't careful, you can or you don't have enough information, you can't always know which end of your graph comes later, which is the earlier period and which is the later period. So you can end up with a flipped mirror image, and that has happened in certain sites where people expected certain things based on preconceived assumptions, and those assumptions ended up being flawed, and we had to go back later and invert the entire chronology. Here's a more complicated example of those battleship curves. You know, in this context, instead of having stratigraphic layers, which did make things simple when you're learning it, instead we have different sites. So now we can look at artifact distributions from entirely different sites and come up with a model of where these sites, when these sites were used relative to one another in time. Now, one thing you see here in this more realistic graph is that the battleship curves, you know, they're not always perfect. Sometimes it's messy. That's the reality of the situation. Now, these particular types, all of these different names, Cougarman, LK Mohave, Hassett, these are all types of projectile points. They're different styles of projectile points. So you can look at this graph and say, oh, based on this seriation of objects, you can use that to create that chronology from 2 slides ago, where they had all the different types of points located at different points in time. This gives you what is called a relative chronology. You may not know you may not be able to give these dates a fixed calendar year, but you know that these contexts, these archaeological contexts, came in earlier in time, and these came in later in time relative to one another. We don't have fixed dates, but we know when things are occurring relative to one another. That's called relative dating. Now, this ends up becoming an extremely useful technique, because once you've done that, anytime you find that style of artifacts, you now know when this site, or when that, you have a date for it. You have a sense of when it happened in time. Maybe not a fixed date, a relative date. And so every time, for example, you find this particular style of point that I'll talk about in a bit, Clovis Point, you know that comes from this particular kind of site, which we now know was used in the Paleo-Indian period. And we know that every single artifact from that archaeological context, from that strata, is going to come from that same period as those points that we found in it. If you find something you can date in a strata, you can then date everything else in that strata. So these projectile points and these ceramic types are particularly useful because they give us a way to date everything else we find as well. Suddenly now we have a reference point in time for what we're looking at. This is just another way of explaining the same concept as the battleship curves. You're not as likely to see this particular kind of graph, but you get the idea of, like, there's a bell curve in which certain styles become more popular, they fall out of popularity, and there's overlap, right? So any time we're digging, any strata or any layer that we're looking at, because a layer could be, for example, a pit, that's a context. All of these things are related to each other in a particular way in that they were buried in the same pit. You're going to find a statistical distribution. You'll find some of this type and some of that other type, and we're looking at the relative quantities of different types. So that was relative dating, right? We're not coming up with fixed calendar points. We're coming up with dates relative to one another. We can also come up with what are called absolute dating techniques. Those are the dates that do give us a fixed point in time. Usually when we do this, the way we get those absolute dates are by looking at something on the level of a chemical analysis of some sort of object. We have many different ways of doing this, looking at the physical properties of different compounds and molecules. But the most common way we're going to see in our work, in this class, is going to be what's called radiocarbon dating. Radiocarbon dating is usually our best and most accurate form of dating things within this general kind of time range. If you want to date something from 2 million years ago, radiocarbon's not going to be great for that. You're going to need other things. But we're going to be in the range where radiocarbon dating is primarily what we're looking at. Essentially, what we're doing here is we are looking for particular isotopes of carbon molecules, carbon atoms, relative to other isotopes. So if you remember from chemistry, which maybe you don't, an isotope refers to atoms that are they're the same type of atom, right? They're all carbon atoms, which means they have a certain number of protons and by extension a certain number of electrons. I think it's like 8. No, 8's oxygen. I forget what it is. But you can look at the periodic table and figure that out, right? All of those are carbons. but different isotopes of the same kind of molecule or atom, the same kind of atom, will have different numbers of things like neutrons. So different carbon isotopes will have different isotopes of carbon. So one thing we look for in particular are specific isotopes of carbon, such as carbon-14, which has, I actually forget exactly how it works, but it has a certain number of neutrons. I forget if it has 14 neutrons or if that's the combined value of the number of protons and neutrons together. Carbon-14 is not a stable atom. It decays. It actually undergoes through a kind of radioactive decay in which it loses, it'll excrete certain particles, protons and electrons, and over time become nitrogen-14, a different kind of atom on the periodic element. Now, here's where things are going to get a little even more tricky. But I guess before doing that, so when we think about carbon, what does that look like archaeologically? Carbon usually is going to refer to something that's been burned. That's usually where we get our carbon samples from. So charcoal is a very common carbon sample. You could also do, there's also carbon in other things like bones, I guess, and seeds, right? Like faunal remains, meaning animal remains. You could, I'm pretty sure. I'm not. I've always only done carbon. That's generally what we're looking at. That's because people make fires. It's common. Carbon is an artifact we find with relative high frequency that is very useful because of this. Okay, so basically, here's how it works. Let's say we're looking at carbon isotopes. What does that mean? So there was a tree, somebody chopped down the tree, turned it into firewood, burned a fire, and then we have the carbon left over in the archaeological record. So that tree, the way it nourished itself was by absorbing different molecules from the air and the soil, right? And so it's going to get a fixed ratio of isotopes, of different isotopes of carbon, based on whatever the atmospheric conditions of that point in time were. So, how do I say this? So, like in that moment where that tree is chopped down and it stops growing, it is going to have a set ratio between carbon-14 to other carbon isotopes in that moment. Over time, those carbon-14 isotopes will start to decay. However, that decay happens very slowly. We measure that decay in terms of a half-life. That's how radiation works. Instead of being a kind of linear, everything, like within 10 years, everything's gone, which we're talking thousands of years, by the way. That was a weird date. Instead, we're looking at every so many thousands of years, half of those carbon isotopes will decay and turn into nitrogen isotopes. So over time, those carbon isotopes will become less and less and less relative to the frequency of more stable carbon isotopes that don't decay. Then we basically use some complex science, which if you are an archaeologist digging in the ditch and digging in the dirt, what this is going to look like is you're going to collect your samples. You'll be very careful to keep them uncontaminated, and you're going to send them into a lab. That lab will do some chemistry on it. They'll come back and give you dates, and then you know the dates. That's how most archaeologists do this, unless you end up working in those kinds of labs. But basically, the idea is this ratio of different carbon isotopes now tells us how we can work backwards to see how long ago that's been. For example, if we find half of the number of carbon-14 that we would have expected relative to other carbon isotopes, that tells us we've gone through one cycle of those half-lives, which is like, I forget exactly, it's 2,000 something years or 3,000 something years, I think. If there is a quarter, that means we've gone through 2 of those half-lives. So we can use this to work backwards and come up with fixed dates in time. These ratios of carbon isotope correspond to an object that is this many years old, 10,000 years old, 4,000 years old, whatever it is. We now have a fixed date in time. The nuance here, a nuance here you have to watch out for, though, is that Earth's atmospheric levels of carbon isotopes is not uniform over time. It changes in different environmental conditions. Meaning that original ratio of different isotopes that that tree had the moment it was cut down are going to be different depending on if that tree was cut down 1,000 years ago or 10,000 years ago, because the atmosphere was different. So on the right, what I have for you is just a simple diagram that illustrates how those atmospheric conditions change over time. So basically, we have a graph. On the one hand, we have the radiocarbon age. That refers to the number we get when we analyze the carbon isotopes in terms of the ratio of different carbon isotopes. Then we have the calendar year on the other side. So basically what you do is you get a date in carbon years, radiocarbon years, which are distinct from calendar years or calibrated years. And we need to calibrate those radiocarbon dates to account for variations in atmospheric conditions over time. So basically you get your radiocarbon age date, you go over to the graph and you see where it intersects that line, and then you go down, and that translates you into a calendar date. Now we can put that, this was 10,000 years before present. So keep in mind, a radiocarbon date is not the same as a calendar date. It has to be calibrated. So you will sometimes see things written as radiocarbon dates or rad dates. You will sometimes see them as calibrated dates or cal dates, which could be calendar as well. So that is your in-depth discussion of radiocarbon dating. The short version is we do chemistry, we do a science on carbon molecules, and we use that. We look at relative ratios of carbon-14 isotopes to other isotopes in order to work backwards and provide a date for that sample that is fixed within a calendar period. Again, this lets you date everything in that archaeological context. If you get a radiocarbon sample that gives you a calibrated date of 8,000 years ago, you know everything in that strata, in that unit, dates to roughly that same period of time. You've now been able to date so many things you're looking at. And you know that the strata before come after that. So even if you don't have a the strata above come after that fact, the strata below come before that fact. So even if you don't have fixed dates for those, you still know relatively that they come before or after the date you do have. Now, so this is a very, very useful technique, so you will see these things a lot. If you don't remember the whole scientific explanation for how we do seriation, what the chemical process of radiocarbon date testing is, sample testing is, that's okay, but at least you can differentiate, right? Like, this is why ceramics matter, this is what we're doing with this is why we're paying attention to styles over time, and this is how we arrive at, and this is what it means when you see radiocarbon date versus calibrated date. All that useful contextual information, even if you don't remember the details. One last point, when you see a date from radiocarbon samples, it's going to give you a spectrum. It'll be like 8,000 years plus or minus 250 years. The idea is that when we do radiocarbon dating, we know that date within a given confidence interval, meaning it's within this, we don't know exactly, but we know it's within this time. Usually the standard practice is that you create a spectrum that plus or minus 250 years means we know, we are 95, 96, I forget exactly the number, percent sure that this sample corresponds to this date within this range plus or minus 250 years. We usually stick within that 95% confidence interval is what we describe. Statistically, sometimes you'll see this described as a 2 sigma confidence interval. Some things you will see in 1 sigma confidence interval, which is only a 66% confidence. We are 66% sure, or 67, I guess, if you round, 67% sure that this date is within these brackets. Usually we try to go for the 95, but you will see both. Okay, next we have lithics. Lithics are a fancy way of saying stone tools. When you see the word lithic, think stone tool. That's it. That's all that word means. When we talk about lithics, I already said we talk about projectile points rather than arrowheads, because most of them are in fact spear points. You will sometimes hear the word biface. A biface refers to a type of stone tool that is worked on both sides instead of just one side. All that word means. Basically, and when we look at lithics, what we're talking about is a particular set of technology that humans developed for making tools out of certain kinds of stone. You really need certain types of stone, chert or flint. Chert is a type of flint. Obsidian works really well. You can also do it with glass. The reason for this is because the crystal structure of these types of rocks like chert are very, it looks almost glassy to the eye, right? It's very smooth. It's not coarse. And that smoothness allows it to be worked in certain ways. Essentially what we're doing is we are creating impact, right? You take the core, we call it a core, you take the big piece of chert that you want to work with, which is the core before you've worked on the rest. And you're trying to split off pieces, and those pieces will either become the tool, or when you're working the tool, you can split off pieces to refine the shape of the tool. When you hit that rock, that core, you're going to send shock waves through the stone. And those shock waves will cause pieces to flake off. Now, if you think about this on a physical level, if your brain works, those shock waves are going to move through the rock in a kind of curved shape. And so when a piece gets flaked off, the result, as you can see in number 2, is this kind of concaved, flaked shape. And then you have several different ways of getting smaller pieces and getting more and refined flakes out as you sharpen it. So first you take the core, you smash it, and you get a big chunk. And then you can fine-tune, you can make smaller, more precise flakes in order to get that shape exactly how you want it. So we can use this to make projectile points, we can use it to make hand axe or scrapers for working hide or knives, any kind of tool you need. This is how people are making their basic toolkits, is with this kind of practice. When we see those concave shapes that I described to you, that is the particular thing that we are looking for that tells us that this is a stone tool and not just a random piece of rock that happens to have a funny shape. I'm trying to remember the exact technical term. It's not something you really hear that much, but it's called like a zone or it's like a curve of impact. It's not a curve of impact, but anyway. We're looking for that concave shape, and it does have a specific name that clearly, like you almost never use, right? Like I've been doing archaeology for a long time, and the number of times I have to use this, unless you're specifically working on this particular kind of thing, doesn't really come up that much. So here, I'm just giving you examples to show you what these different kinds of rocks look like. On the left, that's quartz. The center one is chert or flint. And the one on the right is obsidian. Now you can see with the chert and the obsidian, right, you can see how smooth and glassy it looks. That's what you want. That's what you need when you're talking about making stone tools, or a practice. The word we call this is flint knapping, the practice of making a stone tool, flint knapping. If you look at that quartz, the quartz is a lot rougher. It's not nearly as glassy, right? Quartz is about the lowest quality, roughest rock you can make stone tools out of. It will flake the way you need it to, but it's not very good. People do use it occasionally, but it's not generally considered the most valuable, or it's not necessarily the most useful or pragmatic kind of tool. So you might use quartz if, for example, you don't have access to chert for some reason. Or you might use it to make something that is symbolically or spiritually significant that looks like a projectile point, but maybe isn't as useful, or you wouldn't necessarily use it to hunt, but it's used in a spiritual or ceremonial or otherwise symbolic context. Here's some language about stone flaking. Again, this is something, or flint knapping, this is something that is useful if it's something you're interested in. You can go real deep into it. Otherwise, you just need to know some of the basic concepts in order, so that way if you see these artifacts being written about, you have a general sense of what they are. So here's that core I was talking about. There's that big piece of chert, let's say in this example. And then there's the flake. So basically somebody hit that rock downward with a hammer. The hammer is probably a rock, it could be something else, to knock out this flake. And you can see these kinds of concentric curving lines. That's what we're looking for. That means that's what we see in the flake process, is those concentric curving kind of waves, right? Literally, it is a wave of force that is moving through the rock when we hit it. That is literally what's happening. So flakes are very common. You can take flakes and work them and make them into tools if they're big enough. Some flakes are just trash, which we can also call, using the technical term, debitage. Preform means, we basically made the tool, but we haven't really made it nice. We haven't totally finished it. We got the right shape, but we didn't really sharpen it, or we didn't finish it. Sometimes you do find preforms. Now, that was a lot of language. That was a lot of background for some of y'all. If y'all need to take a break here, go ahead and feel free to do so, and then come back to the rest. That is a lot of background context for those of you who are new to archaeology or just needed a refresher. This is one of the reasons why it's important to cover this stuff right now, is because when we look at the Paleo-Indian period, about 10,000 years ago and earlier than that, not a lot survives that long. Most things decompose. Most of what we see are stones and bones. That's what we have to work with. In later periods, we're going to see all kinds of different things, and we're going to be able to come up with some really neat interpretations based on things that, just based on artifacts that we were able to find that you are not going to see in context this old. That stuff just is not archaeologically visible when you go back this far in time. So understanding what we're looking at in terms of stones, right, and why those stones matter, because they help us do things like create dating and things like that, dating systems. That's why this stuff matters. That's why this particular form of data is significant, archaeologically speaking. It's not just that we love arrowheads as archaeologists and we're into that shit. You'll notice I used that word incorrectly as a way of kind of poking fun. It's that there's a lot of scientific information you can get from these objects if you know how to look. So we're starting in the Pleistocene, which again refers to the geological epoch of the last ice age. The world, the climate looked real fucking different at this point in time. It was a lot colder, and so there was a lot more water that was being held in glaciers and ice sheets, which means that the ocean levels were lower than they are today. So this is what the world looked like. I'm sorry, this is what North America looked like. Just a different shape because different ocean levels. This refers, in the diagram to the right, you see the ice sheets. This is referred to as the glacial maximum, which means the furthest point that those glaciers have reached in time. At the coldest point, at the point where they were at their biggest, that's where they reached, was to the glacial maximum. Now, one thing you might notice is there's actually two distinct glaciers in North America at this point in time. I mean, there's actually a few different ones, but let's just stick to these two. There is the Laurentine ice sheet, and there's the Cordilleran ice sheet. These are actually two distinct glaciers. That's going to become important later on, but it's fine for now. Now, it's also worth keeping in mind that because it's colder, because the oceans are different, the coast is different, that means things like winds and currents, everything is going to be different, and so climates are going to be different. In fact, when I was doing my research, there was a time when this man I worked with was telling me how when he was caretaking this older woman in not exactly the community, she was actually part of the Seminole tribe of Florida, but she was a relative of many of the folks in the community I did my research with, and spent a lot of time, was close friends with people, and actually participated in a lot of the spiritual practices and ceremony with the folks I was working with. So she's a Seminole lady, but closely integrated into the community I worked with. And this man I was talking to was with her while she was dying and helping taking care of her. And he said one of the things she told him was that her people were from this part of the world. They were living in this part of the world, of the South, what later became Georgia, Alabama, Florida, since that place looked like the African savannah. And he said that's really neat because the last time this place would have looked like that would have been the Pleistocene, would have been the Paleo-Indian period. So he inferences that story as being a story about this Pleistocene era. I'm not going to say, I'm a scientist. I don't tend to think of things as true or not true. But it's interesting to think about. And, it's available evidence that you have to evaluate. Now, one of the differences from the Pleistocene is animals were real different, too. We have a lot of what are called megafauna. Fauna refers to animals. Mega means big. We're looking at some big honking animals. Mammoths and mastodons are the most famous ones. And here you can see the difference between mastodons and mammoths. I said last week I often forget. There's all kinds of other things too. There's this species of giant armadillo, and there's giant beavers. Horses, I think, are pretty small in this time period. Saber-toothed tigers. This little elephant rhinoceros guy. There were camels in this time period, and bison. Some megafauna. Most of this megafauna is going to go extinct following the Ice Age. For example, mammoths, giant armadillos, they don't survive after the end of the Pleistocene. However, what's the word I'm looking for? However, there are still megafauna today, right? Like bison are megafauna. Elephants, Indian elephants, African elephants, those are megafauna. Whales are megafauna. They're just big animals. But back then there were a lot more megafauna on this continent. And this is primarily what people were hunting in terms of meat supplies. Now, based on analogy to contemporary foraging societies, meat is not necessarily the most important part of people's diets. It's an important source of protein, and it can be very highly valued, but most of their calories are going to come from plant stuff, not hunting. One reason for this is when you're hunting, things run away. It's very easy to be unsuccessful, whereas when you're planting, you're going to get a lot of food every time you go. It's not going to run away, usually. Usually the plants don't run. Now, of course, that's an analogy to more recent historical foraging societies, which of course is different because there's different contexts. For example, the reasons why people choose to be foraging at later points in time, why they choose to eat that way. There's usually larger context there, like avoiding larger nation states or colonial powers. Also, people aren't eating megafauna in these contexts. So, I can't make that distinction. Again, like it's not that I know these things 100%, but it's a reasonable inference to make. Generally, hunting, just to clarify, gathering plants is the stuff that's actually more important, but hunting we do see archaeologically because we have those projectile points made of stone. And this is what people were hunting. So I'm going to start with the old model of how people first started to arrive in the continent. Again, focusing on that archaeological side of things. I'm going to give the old model, and then I'm going to update you with the new model that we have based on more recent evidence. But it'll just be a little simple to do this. So the oldest model is what's called the Clovis first model, which is the idea that well, let me come back to that. The reason I'm starting with this model, the older model, instead of just telling you the more recent one, is because this is actually what many of y'all would have learned in high school. So I'm going to contextualize that and situate it and update it. So the Clovis first model says, okay, the first peoples in this continent were people who made a particular style of points, which we call Clovis projectile points. I'll show you what those look like later down in the next slide. We find that kind of point across both North and South America. So people are coming in and they're everywhere all of a sudden making these similar kinds of points. The model was that there was a point in the Ice Age, in the Pleistocene, where things were relatively getting a little warmer, and those two glacier ice sheets that I mentioned separated, creating what is called the ice-free corridor that goes from what is today Alaska down into Canada and what becomes the United States much later. So this is the Bering Strait model. The idea is basically ocean levels are lower than they were as a result of things being colder, and so that there is actually a land bridge called the Bering Strait Land Bridge, which today is just the Bering Strait, it's underwater, that connects from the tip of Siberia, of Russia, to Alaska. So people were able to walk from Asia into the Americas. And then they were able to continue going down this ice-free corridor until they were able to access the continent. And until there was that corridor, they were not able to get to the rest of the continent. That explains why we see Clovis sites starting around 13,000 calendar years before present, and for much of the continents we're talking about really 12,000 years before present. But in this northern area we do see it a little earlier because it happened earlier. And so this corresponds to that moment when there was this ice-free corridor. So we see the ice-free corridor, we see Clovis popping up across the continent. We assume that Clovis people were able to enter into the continent in this way. And when we talk about Clovis as an archaeological culture, what I mean by that is that we're looking at sites where they made certain types of material culture, in this case projectile points, in a certain way. That's all we mean when we say archaeological culture. They're making their things in the same way. And so, in particular, these are very long projectile points, spear points. They're worked on both sides, meaning they're bifaced. They're several inches long. There's a scale down here. I said they're usually the size of your hand. Some of them are bigger. One of the things that's unique about Clovis points is they have this thing called a flute within them. If you look closely at that larger close-up shot, you can see that there is a sort of concave piece that goes downward from the center at the bottom part of the point. So what happened was when they were making these points, they flake off this kind of, this flute is the name we give to that. They flake off this flute or this kind of concave space. Now, it's not totally clear why people did this. There's many different models or hypotheses. Maybe it made it easier to tie to the points of spears. Maybe it was useful in that it allowed blood to flow more so you could bleed out prey after you hit them. With these, any number, but whatever the reason, we're not totally sure why, but people started making points in this way. It's different than how they made points in other points at other times. And they used these primarily for hunting megafauna such as mammoths, mastodons. And in fact, part of the Clovis first model, or the ice-free corridor model, is that what people are doing here is they're really following prey animals. And here, what I'm showing you is just a map of the distribution of Clovis points, of sites with Clovis points across North America. Again, there's more in South America as well. Every yellow spot corresponds to one or more sites. Bigger dots correspond to more sites. And you can kind of start to see some of these the patterning in terms of, first of all, we do find these sites all over the place, from the East Coast to the West Coast, people are making the same kind of technology. That's never going to happen again. We do see certain concentrations. For example, people do seem to like it in the East. Seems like a solid place. There's still, big sites places where there's, not big sites, but multiple sites, even hundreds of sites out west, but in smaller areas. So this tells us something about how Clovis people moved through space. They come through that ice-free corridor, and they're moving real fast. They're moving real far. They're covering a lot of ground. They are concentrating. They're preferring certain environments over others. But it's like they show up and they spread fast. And so one of the inferences we can make from this, right, is we are looking at people who are living in highly mobile societies. They are moving across space, most likely following things like seasonal shifts in terms of what food plant stuffs are becoming ripe and good for harvesting, as well as migrations of different prey animals. So one thing that comes up, for example, in the Page Ladson site that you read about, is that this site was in the Paleo-Indian period, it was a watering hole that megafauna would use. I want to say mammoths, but it might be mastodons. I'm just blanking. Mastodons are doing this. So right now, if you look at the site, it is a river. It's under the Oscilla River. But back then, when the environment was different, it wasn't a river, it was a sinkhole. And so it was a place where different animals would come to drink water. And so it was a place within the larger mastodon migration route because mastodon make these kinds of seasonal migrations, right? So human beings could follow those routes as a way of maintaining access to food supply. For this reason, they are, sorry, not for this reason. And so then when those archaeologists were digging the Page-Ladson site, what they were looking for were human artifacts associated with these megafauna. What they found, to jump ahead a little bit, is, and what they were looking for was human artifacts that predated Clovis, that were located in stratigraphic layers that were below the Clovis layer. And they did end up finding it after searching for quite some time. So highly mobile peoples, people are covering a lot of space, a lot of ground. The sites we see tend to be pretty small. These are small gatherings, primarily a few families maybe. Often in human societies, there might be places where people might meet up. So many of these smaller bands might meet up seasonally, but for the most part, they're kind of moving around in these small family units. These sites are small enough that it can be quite hard to find them. For example, let's say you're surveying an area, and you dig a shovel test, meaning you dig that little shovel 10 centimeters by 10 centimeters, or however much it is. I think it's actually not 10. I think it's like 20 or something. It's the depth of your shovel, whatever that is, the depth of the metal part of your shovel. If you are doing those shovel tests on a grid that's 10 meters by 10 meters, these sites aren't necessarily that big. So you could actually miss the site altogether because it's actually in between that stretch of 10 meters. So small, highly mobile family units. Now the problem with the Clovis first model is that Clovis wasn't first. We actually have started finding more and more sites that predate Clovis, where they were using different kinds of tools. Now, for a long time, this was very controversial. People were very adamant, no, that there must be a problem with the dating. Your radiocarbon samples must have been contaminated, for example, or something like that. There must be a problem, or something along the lines that explains this, because Clovis people were first. In part, because how did people get here if it wasn't through the ice-free corridor? Keep in mind that wasn't open prior to Clovis. However, as we find more and more data that supports, yes, people were here prior to Clovis, that is no longer, there are not really people who hold on to the Clovis first hypothesis. It's been pretty effectively disproven. However, we don't have a set date for the beginning of the first peopling of the continent. We're not sure when this started. We have some pretty early dates. It's pretty well established that people were here 1,000, 2,000, 3,000 years before Clovis. Certainly 1,000. Some dates are significantly older than that, but those older dates, there tend to be more questions about them, and it's a site where it's a place where archaeologists debate these things back and forth. And so here's a map showing us where we find different pre-Clovis sites, as well as the radiocarbon dates the dates we find associated with them. So you see on here Page-Ladson, the site you read about. That's from 14,000 years ago. We see a lot of dates in this range, 13, 14, 15,000 years ago. But then you do see occasionally some that are much older. Toca da Tierra Piea in South America, that comes back with dates of 22,000 years ago. Monte Verde is giving us 15,000 years or older. That is something that archaeologists are continuing to debate today. And as a result of this new evidence, the current model for the peopling of the continent is what we would call the multiple migration model. So yes, Clovis people they entered this area through the land bridge. That was one of these routes that people took. However, there were definitely other routes people were taking before that land bridge was open as well. And we aren't sure exactly which route they were taking, but there is a few models. One, and probably the most solidly supported by the evidence, is the coastal migration hypothesis. Basically, instead of saying people traveled over the land bridge and over the Bering Strait land bridge and through that ice-free corridor, people took boats to travel along the coast. That's a pretty solidly supported one by the evidence. It's also possible, this isn't on the map, but it's also possible that people would have arrived through another ocean route, through the Pacific, through the Polynesian Islands. There's not great evidence to support it. However, we do know archaeologically people were seafaring through the Pacific and inhabiting different islands along the Pacific Ocean. And either they just stopped before reaching the continent, or they kept going and reached the continent, right? So it's kind of weird to think they would have just stopped before getting there. Like, why wouldn't they have kept continuing going as they had been? But we don't actually know. Another hypothesis of possible migrations is the Soltrian hypothesis, which is that people migrated from Europe into this region. This hypothesis is based on the observation that certain styles of stone tools, called the Soltrian hand axe, look very similar to styles of hand axe found in the Paleo-Indian period in North America. Now, as a form of evidence, this is a kind of weak form of evidence, right? Like, okay, sure, they look kind of similar. Does that mean that people migrated from Europe, or does that mean that people just happened to make hand axes that looked kind of similar? And you can't really tell, right? But that is a hypothesis. And it's a hypothesis that you will often find talked about in white supremacist discussion forums, because white supremacists love when the continent was first settled by the Americas. It's first settled by Europeans. So that is one that kind of has gained popular traction in certain circles in kind of funny, interesting ways. But essentially what we're looking at is we're looking at people who are arriving in the continent across multiple migrations, including Clovis and pre-Clovis peoples, and who are taking different routes to get here. Now, one thing students often ask is, where did all the megafauna go? Why did they go extinct? I don't actually have a great answer for that. There's, many factors. I mean, climate change definitely did a number. Combined with this population stress as a result of human hunting, various things, there's many factors. However, it's one thing that's interesting to think about is the role that this question and these stories have played within American popular culture. So where I went to grad school at the University of Virginia, and our anthropology department is located in an old building that used to be the Natural History Museum. And in that building, when it was a museum, they had a giant mastodon exhibit, right? And you can see it here. This is a historical photo of that exhibit. There's the giant mastodon, and then there's a skeleton of one of these giant, I think that one's a giant armadillo. It might be a giant beaver. I forget which exactly. Right? But they're putting these megafauna on display. And think about how many times you've gone to a museum and you've seen something like a giant mastodon or mammoth skeleton right in the middle of a big room, center stage. Why are these things so popular and common in our museums? There's a historical reason why. Because remember, museums are old institutions. In the 1800s, when a lot of natural history museums are starting to take off, we are in a very particular historical moment One thing that's happened is Charles Darwin has published this fucking bananas book about evolution. And now, we thought that the world was 5,000 years old based on the Bible. But now, we're getting geological evidence, we're getting biological evidence about evolution that's actually saying planet Earth is way older than 5,000 years old. So it's radically changing our understanding of the world. This raises new questions about what does it mean to be human? Hey, if we weren't given dominion over nature by God, where do humans fit within the world relative to the rest of the other species? These kinds of exhibits in this point, in the mid to late 1800s, are a way that many people start answering these questions. They say, because these exhibits they create a story, right? And that story is, wow, look at these giant, incredible animals that used to walk through the earth. Where did they all go? Why aren't they here now? And the answer that these museums would give, because this was the theory at that point in time, was that they went extinct as a result of human hunting. So where do humans sit in terms of our relationship to non-human animals, the rest of the planet? We're at the fucking top, baby. Master hunters making all these other shits go extinct. Now that narrative's a little less romantic today because we are in the sixth extinction era. They were in the sixth extinction era back then. They just didn't really realize it at the time. But these kinds of cultural ideas were very powerful. Now, today, as I said before, I wouldn't say that the cause of these extinctions is overhunting. I'm sure that played a factor in it, but it was not necessarily the only thing happening, or even the most important one. But we do see the extinction of these animals, and now you have these complicated historical legacies, like how any museum you ever go to for a natural history museum, you're going to see a fucking mammoth somewhere. Now you know why. And so you read about that Page Ladson site. It's just such a freaking cool site. Again, because it's under the Osceola River, the conditions of the site are actually completely anaerobic, meaning there's no oxygen, which means that the organisms that normally would decompose organic matter cannot survive because they need oxygen to do their work, to live. So when I said earlier, looking at the Paleo-Indian, the only things that really last that long, that survive this long, are stones and bones, Page Ladson is a big exception. Because of those anaerobic conditions, we actually have preserved organic material. So fucking cool. That organic material is mostly mastodon poop, like overwhelmingly mastodon poop, which is really like if you've ever seen elephant poop, it's very similar. These are related species. It's mostly like woody material. It's a little different than how we usually think of poop. Very woody and organic. And so archaeologists were digging out these sites from underwater. There's complicated techniques you use to excavate underwater with its own challenges. Here's a photo of the Osceola River and that area where the site is. Beautiful, beautiful place. This is actually where I grew up. My mom was raised in Monticello, right here. And as I said before, they were looking to see, okay, we have all this mastodon shit. We know when the mastodon shit dates to. We can date that shit. Do we find artifacts that predate Clovis? And they looked and they looked and they looked, and then they found that smoking gun that says, yes, this is a pre-Clovis site. Before, we had evidence, we had artifacts that we thought were pre-Clovis, but we didn't have that smoking gun to know for sure. This is that smoking gun. And so basically they were looking for human artifacts that were found in the same archaeological context as this pre-Clovis mastodon poop. Because again, this is a site along migrations. There's a lot of mastodons. They're big animals. They poop a lot. And so we're looking to see an association in that stratigraphic layer. Now, I actually visited this site because my mom's childhood friend was volunteering on the dig. So he introduced me to a bunch of people, and one of the archaeologists took me out on a boat and showed me the site. And then they took me to the lab, which is this building that they were using, like basically a cabin, for the sake of processing the artifacts when they weren't actively digging. And in this cabin, they had the entire porch was just filled, covered, almost every square inch, except for, there's a way to walk, there's a walking path, was covered with gallon-sized Ziploc bags upon gallon-sized Ziploc bags of organic mastodon shit. The technical word for this kind of mastodon shit is called digesta. That's the term for this particular type of refuse. It's not the same thing as a coprolite, which is another kind of poop that we often find archaeology. Coprolite is fossilized poop. Digesta is organic. This is organic poop. And so this site was simultaneously a mastodon watering hole and a hunting ground, because it was just a good place to hunt, because mastodon would gather there. And they had so much of this digesta that they just had more than they really needed to do anything with, right? Like, they did all the tests that they could do to understand, like, the diet of these animals. It was mostly grape plants, grape leaves, like all of that kind of testing, all those chemical analyses they could ever want to do. They had more than enough. And so what they were doing when I got there, it was basically they were putting the digesta samples in water and kind of agitating the water and then scraping off all that woody material that floats until you're left with just the heavy stuff that sinks, which would include any stone tools, lithics. So basically, we're just going through this massive quantity of shit to filter out the heavy materials, and then later they look through those heavy materials that you concentrate out and look for those stone tools. That's how they found that smoking gun. And then, because again, they had done more than enough testing on everything else they needed from it with that woody material they had left, they just kind of left it to compost, to decompose in a pile, right? They didn't need it anymore. It was not scientifically interesting or valuable at that point, which was kind of a shame, but, what can you do? I mean, it makes sense. So anyway, I just thought to myself, like, oh, you know what? I bet some of these, like, Creek folks I work with for my research would really appreciate a bag of mastodon shit. So I asked, and they said sure, and they let me bag up a couple bags of mastodon digesta, which I threw in my trunk and took with me. I actually gave these to a spiritual and community leader who I worked really closely with. He really was someone I worked with a lot in my research, and I became very close to. And so in indigenous communities, one thing that's still really common is like gift exchanges. When like giving gifts is an important way of like showing people you appreciate them, particularly when you meet someone for the first time. It's very it's not that it's like in other societies people don't do that kind of gift giving, but it's definitely very common and culturally encoded in indigenous communities today. So I thought he would really enjoy some mastodon shit. You kind of have to know him to know how much he would appreciate this. And so I went up to him and I said, hey, I just wanted to show you like something that like I wanted to give you a token to show what you mean to me, and like how much you've helped me with my research, and like how that really shows what something about like our relationship and how important you are to me. So I got you this bag of mastodon shit. And I was joking, and he kind of he didn't actually laugh. I actually thought he was mad at me. He didn't react very strongly. I thought I maybe shouldn't have made that joke, and he was pissed at me. But I found out later he told everyone else in the community. He was like going on and on about the mastodon poop I gave him. He was actually quite excited about it. He just didn't show it right away, which sometimes people don't. And he actually ended up adding some of it to the ceremonial space of the community, which is kind of a big deal, right? But it is a practice within this particular community with, like, just taking little bits of soil from different archaeological sites, because those are ancestral places, and it's a kind of a way of maintaining connections with these older places. It's also a way of sharing some of that, like, spiritual power and goodness from those ceremonies with people from those, like, ancestor spirits in those places, and vice versa. It's a way of sharing in that stuff together. And a little after this, I'm about to get in my car and drive to Oklahoma because I have plans to take an immersion program learning the Creek language through a teacher in Oklahoma. And as I'm doing this, as I'm getting ready for this, the guy I was working with, Hagobi is what I call him. That's a ceremonial name. It's not his given name, but it's the ceremonial name I call him in my research. Hagobi, this elder I'm working with, says, okay, when you give it to her, say this to her. I'm going to teach you how to say that in Creek. So here's my Creek language learning. Tell her you wanted to get her something really meaningful and special from the old homelands. So you got her this, and it's Yubel Loage Ajuletari Inalunwat. Meaning, what that literally means, it means mastodon shit. Literally, it means Yubel Loage, that creature with the long limber nose or trunk, that limber-nosed creature, Ajuletare, very ancient and defunct or extinct today. In Halonwat, it's shit. And so, what do you do in language revitalization? Sometimes, language revitalization is something that's really important in a lot of communities, in indigenous communities today. It's a really important kind of social movement that's happening in these communities. And it can be very fun. It can be really connective. And even if you're, I don't know. It's just this kind of interesting moment where here is this, like, thousands and thousands of year old shit that suddenly becomes an important heritage object today because archaeologists didn't need it anymore and were willing to throw it away. Just a funny set of circumstances. I gave some to other people. Like, I made a really close friend in that language program. I gave it to her, and she said she actually put it in a jar and kept it on her mantle next to some dirt that she had gathered from a mound site east of the Mississippi, that she had visited with her dad when she was a child. So, like, very meaningful kind of thing, right? And again, Creek folks the Creek Nation removed in the Trail of Tears to Oklahoma in the 1800s. So there is this kind of ongoing significance of even things like a little mason jar full of dirt from a site from across that Mississippi River. Apparently I had a slide in this PowerPoint that I forgot about Ancient One and Kennewick Man, but we've already talked about that, so I'll just skip over this for now. But here's some of those images if you need to come back and reference from those facial reconstructions. Just a few brief things. One thing we see in this period, we start to see banner stones. Banner stones refer to a type of object. Here's what they look like. Essentially, they are weights for a tool called an atlat. You'll more commonly hear it atl in English, but it's originally a Nahuatl word. And excuse me for my terrible Nahuatl accent, which is an indigenous language in Mexico. An atl is a throwing stick. It's you can see in this picture of someone holding it. It's essentially a stick that reaches out, and there's a notch at the end where you can fit your spear, and you throw the spear with the stick. Mechanically, what that does is it basically extends your arm longer. It makes your arm effectively longer, so that when you throw, the kind of circumference of your arm's rotation is longer. And if you remember some high school physics, that means that end point that's further along, that rotation is going to be moving faster. So you're going to get a lot more power and a lot more force using this tool when you throw a spear. You'll be able to throw a spear harder. You're going to be able to throw a spear further. Basically, you're extending your arm to introduce more centrifugal force into your throw. So banner stones are generally weights that are made for these atlatls. The person in the picture doesn't have one on theirs, but they're made to help with that throwing process. Some of them are actually quite beautiful. Because, people often selected stones for aesthetic purposes to make their things beautiful, as human beings do. Now, we do occasionally find some information about Paleo-Indian art and spirituality. We don't see a lot of it because, again, the preservation conditions are just fairly poor when we're talking about things this old. But we do see certain moments. For example, there is a mammoth bone from Vero Beach, a site in Vero Beach in Florida, that has an artistic engraving. And there's actually a couple things like this, like things with artistic engraving, and people, like archaeologists, look at them and they're like, okay, is this an artistic image, or is this just random marks? And how can we distinguish between those two things? But this is a nice example because it really, you can kind of see, like, it's worn, it's faded over time. Objects change a lot in 10,000 plus years. But you can see some level of art. We do see a particular form of projectile point called Dalton points. In some Paleo-Indian locations, we see oversized Dalton bifaces. These are basically projectile points that are too large to be pragmatically useful. They're also buried in pristine condition, which means people didn't use them. They made them and then buried them without using them. All of that tells us that we're looking at something that is not practical in its use, but symbolic. People are doing this for some sort of symbolic reason, presumably related to art and spirituality, although that is an inference that we are making. And actually, there's a joke in archaeology about this, because whenever we can't figure out what the practical use of something is, we classify it as ritual. Ritual, archaeologically, and it's funny because it's not exactly, it's silly, but it's kind of not untrue either. Ritual is, more than anything, a gloss we use to refer to practices that we cannot figure out the practical significance of it. It appears to be a non-practical form of behavior, so thus we assume it's symbolic and we call it ritual. So whenever you see that word ritual in archaeology, just keep that in mind. What that means in terms of the data is, like, it may not always actually mean what we think it means. It may, sometimes you find out, oh, we thought that was a ritual object, but actually that's a fishing weight. Or we thought that was a ritual object, and maybe it is symbolic, but do we call it, like, is it spiritual? Unknown. Anyway, just more context. The other thing we see are bog and pond burials, for example, from the Windover and Warm Mineral Springs sites in Florida. These are places where we find human remains or burials that are like the Page Ladson site in anaerobic conditions. So we get some really unique information from those kinds of sites. So we don't have a lot of data in terms of art and spirituality in this period, but we have some occasional kinds of things where we do see. And here's some nice kind of diagrams of bog burials. Again, I'm not going to show you human remains in this class. I think there is maybe one example. There's at least one example where I'll show you other diagrams like this. This is an artistic representation. It's not even a diagram, so even one more further step removed. At least in my mind. I mean, I don't know. But so you can see, like, this is a burial within a bog, which was a practice among some people in this period of time. Essentially, you would bury people underwater, and you would create this kind of structure that would hold their body down underwater while it decayed. There's also a particular site, Warm Mineral Springs in Florida, which is within a sinkhole. Actually, what it looks like what happened in this site is that, like, somebody fell in, or maybe was pushed in, unclear, and died. And so we do see some interesting things in those contexts. There's another kind of horror story here of it's a learning experience story. When Mineral Springs, when this site was first excavated, they found this burial, right? And they pulled out the skeleton, and the skeleton still had organic brain matter within it, right? Because of these anaerobic conditions. It still had organic brain matter. And the archaeologist, who is, with diving equipment to do this kind of work, comes up to the surface and pulls the skull out of the water. But once it's removed from the water, that organic brain material just melts away, and it's completely lost. So you got to be careful when you're doing this kind of underwater excavation. We learned from that experience, don't fucking do that. But, that was a pretty big, it was something in this context that was interesting, that would have been very scientifically, there would have been a lot you could have learned from that kind of material. Granted, of course, there are NAGPRA considerations as well. So, assuming that is something that indigenous tribes, and I don't even know how you would determine who is the descendant community at this point, because who's the descendant community? Fucking everyone. We're talking about, paleo period. People were moving all over the place here. So I don't know how that would be answered on a legal level, but or how that was answered with the bones. Anywho, be careful when you pull stuff out of the water in an archaeology. That's what we learned there. And so this is a kind of nice example of Paleo-Indian spiritual practices. Death, right? I said a lot of what we find archaeologically is from people throwing stuff away. We also see burials. When people bury the dead, that's another way things often enter into the ground. And so here we start to see some kind of spiritual practice. And in the textbook, they interpret that perhaps what we're looking at is something where it's seen as particularly spiritually appropriate to return the body to the underworld or the world below. This is an interpretation that they are making based on an analogy to historic and contemporary period indigenous belief systems. Whether or not you can extend these cosmological concepts back tens of thousands of years is, it's a question. Again, we don't know things for sure. We make reasonable arguments and interpretations. However, within this kind of cosmological understanding of the universe, the world is basically separated into three parts. There's the world above, the upper world. There's the middle world, where we humans exist. And then there's the world below, or the other world. Sometimes it's called the underworld, but a lot of the folks I work with don't call it that because they want to avoid any connotations with the Christian concept of hell. This is very different. Basically, the upper world is a world of light, of air, of form without matter or substance. The other world, the world below, is a world of matter, solidness, substance, darkness, dirt, water, as well as chaos. The upper world is associated with order. The lower world is associated with chaos. Another way of thinking about that is transformation. Decomposition, for example, is not, chaos in English isn't exactly the right word, but it is a transformation of that material stuff. That's part of what the other world does, is it physically transforms stuff. And so some aspects of this maybe are metaphorical. Some of it are quite literal, right? Birds are literally flying through the upper world. Trees are literally reaching into the upper world. When I say that it's associated with form and breath and light, it is literally air. Air is literally the upper world. The other world is literally below us. It literally is dirt and water. And we humans exist on the kind of surface between these two worlds, the middle world. And so the idea here, the interpretation that Pocketot and Sassman are making is that people were burying their dead in the Paleo-Indian period in these bog contexts as a way of associating the dead and returning their bodies to the other world, right? As your body decomposes, it is literally joining the other world, which is very important because we need those nutrients for things like the soil quality to regrow, right? Like these things are very much tied together. So again, do we know that for sure? No, absolutely not. It's an interpretation, it's an inference, it is and that is the supporting argumentation behind it. As an archaeologist, I am very comfortable with not knowing things for sure. That's the world I live in. Also, as a Jewish person, like, it's kind of the same thing. Like, that's basically what Jewish theology is too, is like, do we know things? Do we believe things? Not really. Like, for sure? Like, no. We just, like, I don't know, here's the arguments. Here's the arguments behind it. Here's why we would talk about it this way. And that's the Paleo-Indian. A few discussion points that we might come to, that we can come back to on Thursday. Which I think is going to be much more discussion based now that we've knocked out the lecture that I was planning for this week. That leaves us with, a full class for discussion. One thing we might think about is popular cultural representations of Clovis and pre-Clovis peoples, or the Paleo-Indian peoples. For example, when I was in high school, a friend of mine pointed out one of the things she hates college, one of the things that she hates in archaeology, or is critical of in archaeology, is you have all of these kinds of, like, interpretive drawings, right? Like, where artists come in and they try to represent, like, what people may have lived like using the archaeological data we have. But nobody in these representations, in these images, is ever smiling. Everyone's so serious. So we can think about what are the kinds of limits of how we represent the past or think about the past in archaeology? Why aren't people smiling? Why is that so unthinkable? We can also think about the kinds of language that gets used to talk about the peopling of the continent. For example, in the textbook, you would have seen phrases like colonizing the Americas, settlers, pioneers. What does it say about our own cultural worldview that we are then using to make sense of the past, that we are applying or even imposing on the past? That the language we have to talk about this is drawn from the practice of colonialism. That we are incapable of thinking about these historical, maybe not incapable, that's too strong, but that it is difficult or even surprising to try to think through these issues without relying on these colonial framings and ideas that is so deeply ingrained in our worldview. We can also talk more about that balance between interpretation and not knowing, and inference, and where y'all land on some of the different inferences I've talked about or the textbook has talked about. Things that are possibilities or interpretations, but may not be things we can definitively say for certain as the absolute fixed truth. So bring that stuff in, and we'll discuss in class, as well as any questions you have from this PowerPoint in terms of things you have questions about, need clarification for, or just want to discuss further.